Okay, good evening, everyone. Thank you very much for joining us tonight. That's not working. Should now. It's great to meet you all. My name's Luke Stringer. I work for And Digital. I'm a tech principal here at And Digital. My And title is Riff Collector. So if you work at And Digital, you get to choose a second job title to tell you a little bit about, tell people a little bit about yourself. So I play guitar, so my And title is Riff Collector. I've been building mobile apps since around about 2010, and I'm going to be talking about them tonight. So let's start where really the smartphone revolution began, and that was with the invention of the iPhone back in 2007. So when Steve Jobs stood on the stage in 2007 and showed the world this device, it looked like the future, and it did turn out to be the future. It combined a web browser, a communications device, and an iPod. People can remember iPods. This was incredibly revolutionary back then. Hot on the heels, Google released a mobile operating system, Android, which was based upon Linux. They weren't making hardware at the time, so they partnered with HTC to bring out the very first Android phone just the year afterwards. And really, since then, we've seen an absolute explosion of innovation and really life-changing things. We've all got smartphones in our pockets now. And just to put a little bit of context around what we're talking about tonight, it's a huge market. So in 2012, 225 million iPhones were sold. That's quite a lot of money. And 1 billion Android devices all around the world were sold in 2022. This is big business. So it's worth around 336 billion. That's a 14% growth year on year from 2021 to 2022. On average, there's $318,000 spent per minute on the App Store. So it's a huge opportunity. For people using mobile applications, this is quite a scary statistic, actually. A third of waking hours are spent looking at phones. That's perhaps a little bit too much. I'm not going to pass any judgment there. And 485,000 apps are downloaded per minute. And the reason for this is these apps are obviously really engaging, but people spend 7 times more of their time on apps than they do web browsers and web applications. And that's partly because of the things I'm going to be talking about this evening. But on average, they load 6 times faster than browsers. So you can get to the value much, much quicker. So I'm going to be talking about mobile app strategy. So that's just to set the scene. If you decide you want to produce a mobile application, there's a number of things that you need to think about. So we're going to look at what makes a really great mobile app. And the first thing to consider is that we don't just have an iPhone and an Android phone these days. It's a huge platform. In fact, there's multiple platforms that you could describe as a mobile platform. We've got phones, obviously, but there's lots of different sizes of iPhones these days. Wearables are a massive thing, so smartwatches, tablet devices for consuming media and creating media, so with things like styluses and the Apple Pencil. Over the last couple of years, the Android market in particular has really moved into lots of different form factors for mobile phones. So folding phones, where the screen itself folds, is absolutely a thing. And all of these devices really work in sync with each other, including Bluetooth devices, so earphones, maybe smart home accessories. There's far more to building a mobile application these days than just it working on one size of one phone. So really understanding the platforms and how they work. And on Monday, we got a brand new part of that platform as well. So unless you've been living under a rock, you will know that Apple have launched really a really exciting device, the Apple Vision Pro. So this is their virtual reality headset. It can do lots of things. I'm not going to cover it in any detail tonight because it's brand new. But to prove the point that the mobile platform is ever evolving, we now have another part of that you could be thinking about for your own mobile products. So let's have a look at some of the things that mobile apps can do that are specific to mobile applications. So the most obvious one is cameras. So everyone's got a camera on them at all times now, and it's not just for taking photographs. It could be for using things like augmented reality. So this is the IKEA app, for example, where you can visualize the furniture you would buy actually in your front room using augmented reality. Image capture, not just taking photographs of your friends and family, but for example, sending checks. So when I got a check the other day, I thought I'm gonna have to go to the post office. How am I gonna do that? Just take a picture of it in the app, and the bank then uploads it and it works. So another fantastic way there. And also with machine learning and artificial intelligence, object recognition through the camera is something that you can do now. In fact, something I only discovered a few months ago, in the latest version of iOS, if you take a photograph of a plant, it can do plant recognition in the iPhone app itself. I was very excited when I discovered that. All these little hidden things. So if you're going to build a mobile app, think about using a camera and think about using all the ways that you could build an app there. But because these things are on us all the time, you can think about adding to your application extra layers of security. So using the biometrics. So whether that be a fingerprint scanner or a face identification system. So with Touch ID and Face ID. Interestingly, on the Apple Vision Pro, they're actually using retina scanners now. So they'll be using that as a way of securely accessing the device. So if you've got a banking application or an application with some kind of secure data, you might want to think about securing it with biometrics. And of course, your device is location aware, so it can be aware of where you are, give you location-based results, whether it's a map or, for example, in this example, finding your device. Payments is another big thing. So with mobile devices now having near-field communication, you can use them for online payments. So using Apple or Google Pay, you can buy things through the web now rather than having to put your actual details in. Or you can use it as contactless payments. You can build those into apps. So absolutely think about those. And like I said, smartwatches and fitness trackers are absolutely a thing that is now part of the mobile ecosystem. Android provide the Wear OS and Apple provide the Watch OS systems. So you can build fitness tracking apps, health apps for tracking your heart rate, all sorts of things there. So if you're going to build a mobile app, think about those. That's a really great opportunity. Push notifications, you've got your device on you at all times. So it's a really great way to give users real-time information about something that's happening. It might be a sports game or a news article, that kind of thing. Really think about how you can use that as part of your offering to customers to be able to tell them about information. And if you're building an application that does things with text, then really think about how you can use things like Google Assistant and Siri to be able to issue commands to your application using your voice. You can really take use of that. And similarly, speaking those commands back to the users as well is something that is capable now. I'll say Google Assistant is a lot better than Siri. So buyer beware there. So there's some of the mobile-specific capabilities that you might want to think about. However, there are other things as well, some non-functional considerations that you should think about if you're building an application. So accessibility is really important, and baked into all of these mobile platforms now are a number of features that help people with sight impairment, for example. So if you're building an application, consider how it would look for people who have dynamic text sizes, so making them bigger. You need an application that can handle that. Screen readers as well, so people who can't see their device, the device can now speak the user interface to them and tell them where they're pressing on different buttons. Really try and think about that, make your application accessible to everyone. And even people who have motor difficulties, you can enable different things within their application to help them with the actual physical interaction with the device. So it's really important to think about that. And finally, this might be, obvious to most of the people in the world, but I design applications thinking about it being consumed by people in my country who speak my language, but the market now is absolutely international. So thinking about how your application performs in different languages with different language directions, even down to sort of the idioms, the way that you describe things in that language. And then also it's taking a step back to cultural things. So units and measurement, not all countries use the same numerical system. Not all countries put their commas and full stops in the same places. Currency is different. Time and date is different. There's more than one calendar, for example. And you want to think about how your application can work for all of those different customers. So when you're thinking about a great mobile application, it's not just about getting it on a phone these days. It's about considering all of these things. And there's a lot more as well. And it would take me all night to go through them. But there are lots of things that you want to consider if you're going to build a great mobile application. But if you've decided that you want to build a mobile application and you want to make it great, the next obvious question is how are we going to do that? What's the best way to build it? And here, this isn't a simple answer either, but there's lots of different approaches. So I'm going to now give you a little bit of a summary of a number of ways that you can actually go about building a great mobile application. So principally, there are two different approaches that you can take as a software engineer to building a mobile application. The first one is what we call a native application. And these are using the tools and programming languages and technologies provided to us directly from Apple and from Google. So Apple's approach is to provide you with the Swift programming language and all of the tools there. And the Kotlin programming language is actually developed by a company called JetBrains, but Google have partnered with them, and that's their preferred programming language. And the tools that they give you are the ones that they want you to use. They're the ones that offer the best support. We're going to go into a bit of an analysis later on. However, what that means is you write your application once for each platform, And there are other options. You can use a cross-platform solution, for example, React Native or Flutter. And what you do here is you write it once, and then you're able to deploy it twice. So if anyone's familiar with Java, that's the whole model of the Java ecosystem. And we now have that for cross-platform. So React Native originally was developed by Facebook. They're now the Meta organization. And interestingly, Google have created Flutter. So they've also got Kotlin as their native platform and Flutter as their cross-platform solution. So digging into a bit more detail then, as I said, Swift and Kotlin are owned by Apple and Google. They've been around for, this is probably out of date now, they've been around since 2008 and 2007 respectively. Here, each platform uses native components and lays out the application to produce something that works specifically on iOS and specifically on Android. And then you upload them to the App Store and the Play Store, and users are able to get them. This is absolutely production ready. These are the things that the providers themselves say these are first-class components, and you should use them where possible. So they're absolutely production ready. But more recently, we've got some cross-platform tools, for example, React Native. Here, this is an open source framework now, but it's sponsored by Meta, formerly Facebook. The language here is JavaScript, but you can write TypeScript alongside it. Around about 7 years old, so it's a slightly newer kid on the block. However, this is still production ready. There are many applications, some of which here are written in React Native. So the Instagram app, for example, and a number of applications that we worked on at And Digital that I'm going to be talking about later are also written in React Native. And then fast forwarding a little bit more, we have Flutter. And this is perhaps one of the newer things to come out from Google. This is a cross-platform solution, similar to React Native, where you write it once and you can ship on multiple platforms. Interestingly here, this isn't just for mobile platforms. You can also deploy these for web applications and desktop applications. This is really a one-stop shop for everything. This uses a programming language called Dart, which again is slightly newer. It's not as well adopted, but it's the language that Flutter have chosen here. And this is production ready. There are some applications that use this. So the SpaceX application, for example, the Google Ads app uses that, as well as Groupon. This is something that you can absolutely build applications with and deploy them and build a great mobile application. But with all those different options, you want to think about the best approach. So I want to take a little bit of time just to consider how these work under the hood. So in terms of building a mobile application, this is the general architecture that you would follow. So starting from the bottom up, we have the operating system, and this is the software-hardware interface. So we have iOS for iPhones and iPads. We have Android for Android devices. The next layer up are the native frameworks that Google and Apple provide us. They're things that allow us to talk to Bluetooth, the location chips, motion, audio, data persistence, basically the entire feature set. You're able to tap into them. On top of that, we have a set of standardized components. So these are the buttons, the switches, the scroll views, everything you're used to using in an application, they provide you. And then on top of that, you build your custom applications. For a native application, you build them using Swift and Kotlin. Pretty straightforward. They're the tools that Apple want you to have. For React Native, you are writing a single application for it to work across both of those different architectures. So you have a single code base written in React Native. And what that is doing is it's using a JavaScript bridge, which allows the application, when it's being run on a device, to tap into the native UI components from Android or from iOS. So that's why it's called native. So I should also say it's based upon the React framework for web. So if you're a web developer, you might be familiar with React as a framework for building web applications. You can take exactly the same concepts and code and build a native application. This way, it taps down into the native components to actually build the user interface. And finally, to complete the picture, Flutter does something similar. You have a single application that can work on both platforms. But here, rather than using the native components, it actually draws them itself. So it draws the pixels on the screen based on its own components. So a slightly different approach, but achieves very much the same thing. So the question now is how do they compare? So you've got these 3-4 different tools. Which one should you choose? Well, there's an awful lot of similarities between them, is the first thing to say here. Basically, once you've produced an application and you need to give it to users, you're going to have exactly the same problems. And so you need to be able to distribute it. You need to think about subscriptions and in-app purchases. They're very much the same. However, there's an awful lot of differences, though. And this is really where a bit of technical analysis and perhaps some of the information I'm going to share with you now will help you decide what platform you should use to build your application. So let's do a good old RAG analysis. Which one's good, which one's excellent, and which one's potentially poor? So we think about something like UI fidelity. So how well can you build a really rich user interface? Well, the tools from Apple and Google are always going to be the best because they're the things that they give you. They can work the best. They're not abstracted away on a tool like React Native or Flutter. So excellent there. We're saying good for React Native because it's perfectly fine, but it's having to go through that JavaScript bridge, so it's perhaps not as good. You have to sort of think about it differently. Whereas with Flutter, though, because you're using their components, you really can design controls that are very specific, that have got specific animations, specific looks and feels. So that works really well. Localization, so being able to get your application working in different locales and different time zones. Again, native is always going to be better. React Native and Flutter are fine. You can do those things, but because it's abstracting across the two, it's a little bit more difficult. Accessibility is similar to UI fidelity because you can build the user interface with a really high level of fidelity. You can also get really nice fine-grained control of accessibility. So how big the text size is, for example. And then if you're looking to adopt new features that Apple and Google bring out, and you want to be the first to market, really native is the only way to get there, mainly because React Native and Flutter have to build support for them, and they're always catching up. So that's something to think about. Some other things, so if you're wanting to do Apple Pay and Google Pay, really the only way to do it is through the native components. It's not possible, or it's very difficult to do them in both React Native and Flutter. If you wanted to build a watch app in watchOS or Wear OS, again, you've got first-class support in native. As far as we know, it's not possible in React Native. There might be a way. The landscape is changing very rapidly, but as of this point, we don't know a way. And Flutter is a little bit more clunky, so I wouldn't recommend that. In order for your application to run on different devices, so phones and tablets, again, native is always going to be the best. But React Native and Flutter allow you to do that. They work similarly to a responsive layout on a web browser. So as you expand and contract the window, it uses a similar sort of way of building an application for different widths of devices. And then finally, old OS support. So if you're wanting to support many versions back of the operating system, native is great, as is Flutter, but React Native is a little bit more tricky to think about. So finally then, just to complete the picture, so if you're thinking about your technology approach, you also want to think about the skills of the people in your team. So how are you going to take a team of people who know one set of skills and give them the skills to build in a different technology? So if it's native, you might find that quite difficult. So we've labeled that as poor here. And that's mainly because those languages like Swift, they're either in your business because you've already got native apps, or they're probably not there. There are no real applications for Swift other than a native mobile build. Kotlin may be there because it's based on a Java language, but again, it seems unlikely. React perhaps is quite good actually, because you might have React web devs who can, without too much difficulty, reskill to become React Native developers. So that's quite a nice avenue. And Flutter, Dart as a language is pretty new. Its only real application is in Flutter. So you're probably not going to have those skills in your business. Whether you have those skills in your business or otherwise, you might think about recruiting for them. So again, you can recruit for all three of these. But at least what we're seeing in the West Yorkshire area, the ease of recruitment for native is harder. So there are less native developers. And from a market point of view, they can command more money. So that's perhaps a little bit harder to recruit them there. React Native, the market is really pretty good, at least compared to the other platforms here. There's a lot of JavaScript developers, a lot of TypeScript developers. And like I said, React as a web framework means it's quite a transferable skill over to React Native. Unfortunately, Flutter, there just aren't that many skills on the market for Dart because there isn't that much demand for Flutter at the minute. But then the real question, if you're a business person, is what is this going to cost, right? And this is, it just depends. It's very difficult. It depends on the application you're building. It depends on the market that you're operating in. However, as a slight rule of thumb, the native applications are probably going to cost you more because you're building them twice. There are massive exceptions to that. Again, it depends on what kind of application you're building. But if you're wanting to build an application that exists on more than one platform, then it's hard to argue that building it once and deploying it twice, either with React Native or Flutter, is going to be better in terms of your cost footprint. But it all depends on the situation. But in terms of the actual philosophies of these applications, build once, deploy twice, that is something you need to think about in terms of cost. So finally then, let's put some more specifics to this. So I'm going to give you a quick tour now of some of the mobile projects that we've worked on at And Digital, how we've tried to build really great applications based on everything I talked about at the start for our customers, using different frameworks and different technologies, and how we've succeeded, or hopefully succeeded in them. So first of all, there are principally three kinds of projects that we often engage in our customers for. The first one is a new greenfield application. So that's when a customer wants to build an application from scratch. They come to us and say, help us build it. The second one is an application that has already been developed, and it's a brownfield update and improve. So there might be new features that they want to add, or they know that the application is perhaps not stable, or they want to add some more features that they just don't have the skills in-house to do. That's the second kind of project. And then the third kind of project is the re-platform. And that's where you go from one of those technology stacks to a different one, maybe to reduce costs, maybe to enable to go to your customers quicker, make it to market faster, for example. And we've got experience with pretty much all of these in the different technology platforms. So hopefully you'll recognize some brands here. We've got BA Systems there as a new a greenfield native application. Applications that we've worked on that we've updated: Subway, Yorkshire Bank, Funky Pigeon as well. In terms of React Native, we built the Answer Rewards application. That was a brand new application. Over in the Flutter column, we've worked on a number of internal projects to explore the technology and really see how whether or not that is 100% production ready, whether or not there's going to be any demand for our customers from it. But I'm going to focus now on this little section here, so the re-platforming. And we've done a number of these projects. Personally, I've been working with Sky and the MyScout for the last 18 months, re-platforming from native to React Native. And there's a bunch of learnings that we've taken from that I want to share with you now. So when a re-platform from native to React Native, the principal job here is to go from two code bases, one of them written in Swift and one of them written in Kotlin, to a single React Native code base that can work on both of them. It sounds relatively simple. There are two aims. The first one is to simply rewrite all of the features in React Native, so aim for feature parity. So users really should be able to use the exact same features as they were before. And in that same vein, they shouldn't know anything that's happened. It should be a seamless upgrade. They shouldn't know that you've done any technical work whatsoever. They're only interested in using the product, not how it's built. So with those two aims in mind, if you're going to approach a project like this in future, there's a number of things that are worth considering. So when you're rewriting all of the features in React Native, you want to have a really keen understanding of what those features are. And we follow the Scrum process with Sky, and this has worked fantastically well to be able to understand the value in the product, working with a product backlog, giving that work out to various different Scrum teams who are working on value streams so that we can continue to deliver features into the product. And the rewrite started absolutely from scratch. So we spent the best part of a year rewriting all of these features to a point where we say the product is now back where it was and we can now release it to the customer. So you want to choose a delivery process that allows you to do that, and Scrum worked fantastic for us. If you're rewriting the features in a different language, you also want to consider how you're going to do that from a technical level. So how are your current developers going to learn new skills? And there's two pathways into being able to do this. The first one is native developers who are used to working with languages like Swift and Kotlin, which are object-oriented and strongly typed, which means they are compiled. They're used to using applications like Xcode and Android Studio. They're also really immersed in building mobile applications, so they'll know what a good mobile user interface is. They'll know how emulators and simulators work, and they'll understand the murky business of app signing, so to be able to create an application that can install it on devices. However, the other path might be web developers who've worked with the React tool on web, and they're used to a very different tool set. So they're used to working with functional programming languages like JavaScript. And unless they're using TypeScript, JavaScript is a weakly typed language, so it's very different in terms of its philosophy. That allows applications to load on the fly. There's no compilation. They're used to tools like Visual Studio Code and NPM and all of the web tools there. And they're used to building web applications. So if you're wanting to rewrite into React Native and you have these two cohorts of engineers, you want to, at the end of it, come out with a bunch of really confident React Native developers. And the way to do that is to think this is actually a complement of the two skill sets. So a seamless upgrade, you want to use the same identifiers, so the application will install over the top, so you've got an upgrade, and that will allow you to do it on both iOS and Android, so that's good. But also in terms of the user experience, you want to keep their session the same as it was before, so they want to remain logged in. If they've got items in their basket, for example, they want to be there. They shouldn't know anything's happened under the hood. So in order to do that, you need to consider these things. So I'm going to close there. That's a bit of a tour of what you can do in terms of designing a mobile strategy. In summary, though, make sure to choose the right platforms. There are a lot of them now. And once you've chosen those platforms, really make use of them. Don't just build a web application. Think of how you can build a really great mobile application. And that should be great for everyone. So it should be accessible for people with any kind of accessibility or motability concerns. Again, for people who are in the international market as well, think about that. When it comes to the technical side of it, think about the best build approach based on all of those different things that we talked about. So features and cost and skills. Don't be afraid to reevaluate your build approach. We work with a number of customers who've decided to move to a different platform, and it's been an absolute success. Plan what skills you're going to need, but really keep the users in your mind's eye. Their experience absolutely has to come first. And whatever you decide, the experience needs to be top notch for them. Yeah, absolutely. So the question from Tosin is around the release process. So if your application is built in a native language, is that going to be harder because of the App Store and the Play Store? The answer is that it won't be any harder. Once you've created your application, regardless of how you've got there, whether it be in a native language, a cross-platform language, or however, you've still got to upload it to one of those platforms. Now, maybe implicit in your question, Tosin, is around, are Apple going to be okay with you using one of these approaches, so React Native, because it's not the tool that they're promoting. There are thousands of applications that are built in languages that aren't directly from Apple and Google. It would be bonkers for them to close the doors, because that's a massive revenue stream for them to be able to create, to get a share of those different products. So they really won't, I can't see, be a reason why they will start rejecting applications that are not written in those native languages. But once you've created your application, you've got to distribute it through one of those mechanisms regardless.